20 is this.
Yes.
So we have f of x equals x squared plus 3x to the 7th power. Very good. Awesome. So we want to differentiate this, and let's do it. So f prime. Anyone would like to help?
It's 7x squared plus 3 to the power of 6, and then it should be times I'm so lost. Oh, 2x plus 3.
That's it. We don't have anything else. Times the inner function prime. 7, the function to 7 minus 1, times the inner function prime.
And that's it?
That's it.
Forgive me if I'm wrong, but I think that question was f double prime
Oh,
of x.
thank you.
Yeah, it was double prime.
Okay. Very good. I covered the problem. I didn't read it. Very good. Awesome. Excellent. So let's continue with the second derivative. So now it gets a little bit more complicated. Let me use a different color, because now this is function 1 and this is function 2, because now this is a product. So keeping that in mind, very good. We have 7 outside, and we open a bracket. So remember the rule. First function prime times the second plus the first times the second prime. Do not change your style. I saw in some of your homework you use the twisted method, which is fine. It works, acceptable. Good. So, but if you're using 1 prime times 2 plus 1 times 2 prime, let's do that. Can anyone give us 1 prime?
Is that 5? Oh, I mean 6, x squared plus 3x to the power of 5. Oh, and then 2x plus 3.
Good. Times 2x plus 3, I will write 2x plus 3 squared. So I have this, and I have this, and I have the plus. Now I copy number 1. And I have to differentiate, so I have this. Now I have to differentiate the second function.
It's just going to be times 2.
That's it. And now I'm going to... Yes, please.
So I kind of multiply 7 by 2x and plus 3. Is that okay, or?
Absolutely not.
Okay.
So excellent question. Okay.
That's what I said
7,
as well.
2x plus 3 squared. By the order of operations, what do I have to perform first?
For the first, no, I was talking about the first prime, like f prime x equals.
Oh, you mean you distributed 7 in here?
Mm-hmm. Yes.
Don't. You're making the problem more complicated. I understand the question now. Sorry, I thought you were distributing somewhere else. Sorry about that. So I don't recommend that. You will see what happens in a minute. I'm not saying it's wrong, but you're making everything more complicated if you do that. So allow me to finish it up. Very good. Awesome. Very good question. See, that's why we're here, right? If you don't ask questions, I will not know how you think and what needs to be addressed. Okay. So, yes?
Where did the power of 2 come from above 2x plus 3?
So when I differentiate the inner, I have 2x plus 3 times 2x plus 3 is 2x plus 3 squared.
Oh, okay, thank you.
Thank you. So we had another one, which was the same. So then I wrote it as 2x plus 3 squared. Is that better?
Yeah.
Okay, perfect. So leave the 7 outside. It's a problem. Okay? It has to wait. Don't involve that 7. It will make your numbers much bigger, and it will make the simplification more difficult. Leave it out. It's not going to go anywhere, I promise you. So now look what we have. I see that this term and this term have 2 in common and also have x squared plus 3x in common. To which power?
5.
Excellent. The smallest of the 2. Awesome. So from 6 we took out a 2. So there is a 3 left, right? From x squared plus 3x to the 5th, we took them all outside. And I still have a 2x plus 3 squared. And then plus, the 2 is out. And from 6, I took out 5. So plus x, I meant to write x squared plus 3x. So therefore, now I can say 7 times 2 is 14. I can copy the x squared plus 3x to the 5th power. And then here I can simplify by, first I have to square this, which is 4x squared plus 2 times the first times the second, 12x plus 9. And I will distribute 3. So 12x squared plus 36x plus 27 plus x squared plus 3x. See why this 7 would have messed me up. The numbers would have been much more difficult to calculate. So leave it alone. X squared plus 3x to the 5th, and then 12 plus 1, 36 plus 3, and plus 27. And no one can further simplify this. This is done. So always keep the constants outside. They can wait patiently till their turn comes and I want this factored. I don't want to do anything with this. It was a very good question. Is this better? Is this clear?
Yes, thank you.
Thank you.
If we do distribute like the 7, is it considered wrong?
No, but then you have to pull it out to completely factor it. So what's the point in putting it here when all the numbers will be more difficult, all my calculations will be more difficult, and then at the end I still have to factor it out
Right.
to make the expression as easy as possible. No, it's not wrong, but you work much harder. And then you, at the end, you still have to pull it out. You see what happens in chapter 3. That's why we need it in the factored form. Very good questions. The interaction is the most important. You ask questions and we answer them together. Anything else? Okay, so moving on. I like to review for test 1. And I would like to present another list of concepts that we want to always have handy for the test and for the final exam. And then you'll tell me what you would like to start with. And please remember there is an old test with solutions posted at the top, in the top module, please. Okay. So again, the concepts that are very important. Number 1, we had these 4 concepts. I'm going to write them again. Average rate between 2 points. So we will be given x1 and we will be given x2. We will immediately find f of x1 and we will find f of x2 and determine the average rate. As we know, f of x2 minus f of x1 over x2 minus x1. This is nothing to do with calculus. It has a lot to do with calculus, but this was from algebra. And we reviewed this in R. Very important concept. Number 2, the rate of change. The rate of change is f prime. Now, number 3, a rate of change for x equals any number. I'm going to put a. That is f prime of a. And this answer is a number. This answer is a function. Function, f prime of x. But I could be asked to find f prime of x or p prime of x or r, revenue or cost or a profit, who knows. When I'm asked to evaluate it, it will be a number. Please remember that this rate of change, like this rate of change, like this rate of change, their measurement unit is composed of two measurement units. So it's something over something else. That's the measurement unit. Meters per second, feet per hour, dollars per unit. So please remember the measurement unit for any rate of change is composed of two measurement units. Okay, number 4. Last time we looked, and also before, we looked at average cost, which is not the average rate, it's not the rate of change, and it's not the rate of change evaluated, in other words. No, the average cost is C of x over x. Profit, average profit, it's P of x over x, which we also know it's revenue of x minus C of x divided by x. And the same thing with revenue, which is R of x over x. These are average cost, average profit, average revenue. I could be asked to find the rate of change. Rate of change of this, this, and this. So I will have to find C of x over x first and then differentiate. I will have to find R of x over x and then differentiate if it's rate of change of revenue, if it's rate of change of cost, or if it's rate of change of profit. So these are concepts that we have to remember and understand the difference. Okay. Another very important concept.
Can you go back for 1 second? Yeah.
Of course, yes. I'm going to post all this, right?
Okay. Yeah, thank you.
Sure. The other very important concept is formal definition of f prime. I'm not talking about differentiation rules. I'm not talking about differentiating x prime and getting 1, or differentiating the square root of x prime, the square root of x, differentiating the square root of x and getting 1 over 2 the square root of x. No, I'm talking about the only one, the formal definition of f prime. Can anyone give us the formal definition of f prime? And there is only one.
Is it f prime of x times x prime?
Careful. Formal definition. You're talking about the chain rule. I'm not talking about the chain rule. I'm talking about, we'll get to that in a moment. You're ahead of me. So that's always good. Formal definition. There is only one formal definition. It's complicated. It's not easy to work with, but there is only one definition. And it involves two concepts together. I'll put it in parentheses. Two concepts put together. This is what we wrote at the beginning of chapter 1. And this is a very important definition. And we looked at 3 different types of functions. We looked, Yes, don't forget what you want to say. I just want to emphasize that we looked at something like the square root of 2x plus 1. We looked at something like negative x squared plus 2x plus 3. And we looked at 1 over x. 3 different functions. Square root, quadratic, rational. And now I'm ready.
I might be wrong, but is it dy over dx? Or no?
It's the same notation, the same thing. It's the same thing, but the formal definition.
Oh,
Two concepts. Two major concepts that we talked about in this class. Two major concepts put together.
Is it the limit of h equals 0? Then I don't remember the name of it, but it was the f of x plus h minus f of x over h.
Very good. So this is called the difference quotient. Excellent. Two concepts. The concept of the limit, and the other concept is the difference quotient. So you will have a question like this. So we are going to work on a problem in a moment. Okay. What other concepts? Of course, number 6, piecewise defined function. I don't think piecewise defined function. I hope we don't need to do this again. I think we had like 5 or 6 examples like this. And finding limits. 7, continuity at a point. You will be asked this definition. Can anyone give us the definition of continuity at the point? Function is continuous at this point. Why? So let's say this is a, and this is f of x. What did we say? Why is this function continuous at that point?